Hello guys, this is CodeNCode and this is video tutorial for the problem two devices taken from Codeforces, right? The problem is rated 2000, right? And the number is from number theory. The problem is from number theory category and we are going to solve it, of course, using number theory concepts and of course, constructive algorithm, right? So yeah, I'll explain it in as much depth and detail that by the end of this lecture, you'll be able to solve these kind of problems yourself, right? So let's get started. Let's start with the problem statement. That is, you are given an integer n, and of course, you will be given n integers, right? So n can be as large as 5 into 10 to the power 5. These many integers can be given in the worst case, right? So for each integer, you have to find their two divisors, and both of them should be greater than 1. Yeah, so for each integer, you have to find two divisors. Both of them should be greater than 1, and it should be such that d1 plus d2 and ai should be co-prime. That means the GCD of d1 plus d2 comma ai, the ith number for which we are calculating two divisors, should be 1, right? So if we understand the same using an example, let's say ith number is 12. We are calculating two divisors for 12. There I have given two examples. There can be more, right? So d1 and d2 could be 2 and 3. Both of them are divisor of ai, and d1 plus d2 comma 12, which is ai. If you look at their gcd, it comes out to be 1, right? 5 comma 12, gcd of 5 comma 12 is 1. They are co-prime. Similarly, you can choose d1 and d2 as 4 and 3. Another example, both of them are divisor of AI. And if you look at it, 4 plus 3 is 7, 7 comma 12, GCD of these two is again 1, right? So these two are valid answer. It is possible that you may not find such divisor pair, or one of which is equals to 1, right? Or yeah, since the AI will be greater than or equal to 2, right? So it will be minimum 2. It is possible that one of them is either equal to 1, or basically you are not able to find valid pair such that their sum and AI, their GCD is 1, right? So in that case, you can print -1, -1. Otherwise, you have to print D1 and D2 for each n integers, right? So this is the problem statement. Hopefully the problem statement is clear. Let's take a look at the solution. So what I'll try to do is give you some hints, observation using which you can try to solve the problem yourself, right? As I have been doing in previous lectures. So let's break down the problem. I will start with observation 1. Our target is to make that d1 plus d2 comma ai is equals to 1, right? The GCD of these two is 1, right? That means there should not be even a single prime common between ai and d1 plus d2, right? Even if a single prime is common between these two, then their GCD cannot be 1, right? So this is that. And I can extend this to say that not a single prime should be there, should be common between all three, right? AI, D1, and D2. So between AI, D1, and D2, not even a single prime should be common among these. If even a single prime is common among these, the GCD is not going to be 1, right? It will be, at minimum, it will be that common prime, right? So yeah, observation 1 is pretty obvious, but sometimes obvious things help you solve this problem. So remember this, between D1, D2 and AI, there shouldn't be even a single common prime number, right? As simple as that. Now, observation number 2, right? I am taking example AI as 120, oh sorry, 180. So its prime factor would be 2 into 2, 3 into 3, and 5, right? So I'm taking AI this as an example to explain it better. Observation 2. Now, see, I'll try to, I would love to hide that and explain thing first. Right. See, we want that D1, D2, and AI should not have anything common. Not even a single prime should be common among them. How we can make sure that, right? First thing first, it is our choice to choose D1 and D2. That means we can actually fix these ourselves. We can decide what D1 is going to be, what D2 is going to be, which is a huge thing. That's why this is going to be a constructive algorithm, because we will decide what value D1 should be and what value D2 should be to get an answer. Right. So first thing is that they shouldn't share any prime numbers, right? D1, D2, and A1 by observation 1. So see, there are certain primes in AI, right? And in our case, it is 2, 2, 3, 3, 5. That means 2, 3, and 5. How can I make sure that D1, D2, and AI do not share anything? We won't talk about any other prime, only the prime which are inside AI, right? Because only these could be common if we don't pick D1 and D2 carefully, right? Since 7 is not here, so 7 can never be common among these three, right? So we only talk about the primes which are present in AI. Now, how can I make sure that nothing is common between D1, D2, and AI, right? One way I can do that, since I know I'm dealing with three primes, 2, 3, and 5, I'll divide these prime among D1 into D2 in such a way that D1 has certain primes, D2 has certain primes, but there's nothing common between them. Can you do that? Of course, we can do that because it's up to us to decide which divisor we are going to pick, right? So what I'm going to do is that I'll give one prime to D1. I'll basically say D1 is equals to 2. One of the prime I have given to D1. So I'll say D1 is equals to 2. Since this is a prime from prime factor of AI, it will clearly be a divisor of AI, right? So I'll give one prime to D1 and the remaining to D2. Now they don't have anything common, right? This way, we can make sure that D1, D2, and AI share nothing, right? So what I'm going to do, I'll give one of the prime to D1 and the rest of the primes to D2, right? So one of the prime, you can pick any prime to give it to D1. I'll go with SPF, that is smallest prime factor. I'll go with the smallest prime. Why? Because we have to calculate the prime of each number, right? AI can be as large as 10 to the power 7, remember, right? Now, I haven't told you about the constants, but I'm telling you now, AI can be as large as 10 to the power 7. So we have to calculate prime factor of all the numbers till 10 to the power 7, which is huge. So what you can utilize? You can utilize Sieve algorithm. If you do not know what Sieve algorithm is, Sieve algorithm can help you find out prime numbers in a range, right? In n log n time, right? Now, if you don't know about that, I'll put the lecture link of Sieve algorithm in the description of the video. So I'm talking about you can give any prime to D1, but I'll go with SPF, smaller prime factor, because I'll utilize Sieve algorithm to find out smallest prime factor of each number that I can do in log n time, right? My bad, n log n time. That's why I'm going with SPF. So I'll take the smallest prime factor, give it to D1, and then remaining, I'll give it to D2. Remaining means take AI, divide AI with smallest prime factor as many times as you can, right? So in this case, you can divide it by, you can divide it two times, right? P raised to power K is basically how many times it appears. K is how many times it appears in the prime factor of AI. It appears two times, so you'll divide AI with 2 raised to power 2. Basically, remove all of the 2's from AI, and whatever remains 3, 3, and 5, give it to D2, right? You can directly give 3 and 5 to it, right? You don't have to give 3, 3, and 5 to D2. You can directly give 3 and 5 to D2. I'm going this way because it would be easy to calculate. You can find out SPF in a constant time after and log n pre-processing. Then once you have the smallest prime factor P, you can simply divide AI with P as many times as you possibly can, right? Without leaving any remainders. And so this will be easy to calculate. This way, we'll make sure that D2 gets all the other primes, right? So this way we can get D1 SPF and D2 all other primes, right? This way we can get our answer. So you see, we had a problem. We took a simple observation that D1, D2, and AI should not share any prime. If they share even a single prime, the GCD will be at least that prime, right? And we want their GCD to be 1, so we need to make sure they share nothing. To make sure they share nothing, what we do, whatever prime AI has, we give one of the prime to D1 and the other, all the remaining to D2. This way, we make sure that they share nothing, right? So, for this solution that we have built, there will be two cases. First, AI only has one prime, like 32. 32 only has one prime, that is 2 raised to the power 5, right? Only two. Now, AI only has one prime. In this case, there will be no solution because no matter what D1 and D2 you choose, since all of the divisor, D1 and D2 are divisor of AI, all of the divisors will be of power P, right? P is one of the divisor that is inside A. So A has only one prime, let's call it P. So all of the divisor of AI will be of the power of P. So in this case, AI only has 2 as prime. So all of the divisors of AI will be power of 2. 2, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5. These are the divisor of AI. Right? Now, since all of them are uh, power of p, right? All of the divisor are power of p. So no matter what divisor you give d1 and d2, they will always have p common. That means you won't be able to find out d1 and d2 in such a way that nothing is common between them. You will always find p common. That's why if AI, the number for which you are calculating two divisor, has only one prime, right? Solution doesn't exist. Case 2 is that there are more than one primes. In that case, solution always exists, right? In that case, solution always exists. I'll prove it also in the next two slides. Don't worry. I'm just explaining how we can find the solution simply. So you can first of all, when you have AI, you can find out smallest prime factor of AI, give it to D1 directly. Let's call it P. Now, as many times as you can divide AI by P, keep on dividing that, right? And so basically, we are making sure that uh, no prime P exists in AI, so that we can give it to D2, right? So this way you calculate D1, this way you calculate D2. To calculate SPF, you will utilize C algorithm. We have D1, we have D2, right? And I'm saying that if by the previous slide, if AI has only one prime, right? If it has only one prime, of course, D2 will reduce to 1, right? In that case, if D2 is equals to 1, solution doesn't exist, right? By case 1. By case 2, solution exists, and it's D1 and D2 is one of the solutions. There can be many, but we are going with D1 and D2, which is SPF of AI. And then after dividing by P, whatever we get, that is D2. Now the thing is, why for case 2, when AI has more than one prime, solution always exists? Why is that so? Let's go ahead and prove that also. Right. I'm again taking example of AI is equals to 180 just to explain you. Whatever I'm going to explain, you can generalize it to so it would be true for any AI. Right. Now, so first of all, now we are going to prove that whenever AI has more than one prime divisors, prime in its factors, solution always exists, right? So let's go ahead and prove it. So to prove that, we will go through all of the primes of AI. Right? Let's talk about all of the primes of AI. Now, since we have already picked P, the smallest prime factor here, we have already picked P, that would be smallest prime factor. We already have that. We'll try to prove it in respect of P. Now, if you pick any prime of AI, be it 2, be it 3, be it 5, right? Let's call it Q. You can pick any prime of AI, it would either be equal to P or it would not be equal to P, right? Only two cases will be there, right? In our case, we picked P to be 2 because we are picking smallest prime factor. P is equals to 2. So now when I'm going through all of the primes of AI to prove this, so prime will either be equal to 2 or 3 or 5. So two cases, the prime Q that I'm talking about, all of the primes of AI, I'm calling them Q. So Q can either be equal to P, that would be case 1, or it won't be able to, it won't be equal to P, right? And we'll prove that in both of these cases, solution actually exists, right? That means solution always exists when AI has more than one devices, right? Sorry, more than one prime device. So let's talk about case 1, when any prime that we pick, basically the prime that we have picked is equals to P. That means the first divisor. If that is the case, Q divides D1 because D1 is clearly P and P is equals to Q. So Q divides D1 but not D2, right? Why Q doesn't divide D2? Because Q is a prime and we have divided the prime among D1 and D2 in such a way that whatever prime is given to D1 is not given to D2. That means if Q divides D1, it won't be able to divide D2, right? So basically, if I have given D1 2, D2 would not have 2 at all, right? So if Q divides D1, it won't be able to divide D2. That means the GCD of these two would be 1. Why? See, the reason is that since we are seeing whether we can find out, we are taking Q. We are trying to find even a single prime which is common between d1 plus d2 and ai. We are trying to find that, right? And first prime we picked is q, and that is first case where q is equals to p, right? So q clearly exists in a1, right? If we can prove that, so basically q divides ai, right? So if we can prove that q cannot divide d1 and d2, basically d1 plus d2, it can't divide that, so you can't find common between ai and d1 plus d2. That means if you can't find anything common between these two, gcd is going to be 1, right? So see, clearly q divides ai, but does it divide d1 plus d2? Let's see. If it divides d1 plus d2, d1 plus d2 modulo q is going to be 0, right? We already know d1 plus d2 modulo q is equals to d1 modulo q plus d2 modulo q, right? And overall modulo q. Now q already divides d1 because q is equals to p, right? So q divides d1, so d1 modulo q is going to be 0. Now we are only left with d2 modulo q. So d2 modulo q is going to be d2 modulo q, right? Now d2 modulo q is not equals to 0. That means this prime q doesn't divide d1 plus d2 completely, right? Why? Now we have already proved that, right? That means we cannot find, we cannot take out q common between ai and d1 plus d2, right? So that was one case when the prime that we picked, right, was equals to p. Now the other case, when prime that we picked is not equals to p, that means we have picked either 3 or 5. What we are trying to do here, we are trying to find even a single common prime between d1 plus d2 and ai. So first case, when we have seen, when the prime we picked was equals to p, we have seen that it doesn't divide d1 plus d2, right? So we won't be able to find anything common between ai and d1 plus d2. Second case, when the prime that you have picked q is not equal to p, that means either you have picked 3 or 5. In that case, again, q would definitely divide d1. Oh, my bad. Q would definitely divide d2 because all other prime other than the q are given to d2, right? So it would be one of those primes. It would either be 3 or 5. So clearly q would divide d2 but won't divide d1, because whatever prime d2 has, d1 doesn't have. So if q divides d2, it is one of the primes of d2, right? Either 3 or 5. That means that factor d1 doesn't have, because d1 has different prime. So clearly q won't be able to divide d1. Again, you can prove that q won't be able to divide d1 plus d2. That means you won't be able to find anything common between d1 plus d2 and ai, right? No matter whether your q is equals to p or it is not equal to p. That means if no matter whatever prime you pick out of ai, it won't be able to come out as common with ai, right? That we have proven using these two cases, and hence for all of the cases solution will exist. Only two cases were there and we have proven. So if you divide primes properly, 1 prime to d1, rest prime to d2, your solution will always exist, right? So let's go ahead and take a look at the solution. So I think I have the solution with me. Just give me a sec. All right, so here is the solution. See, so first of all, just this is nothing but a for loop that runs from 1 till n, rep 1 comma n. Sorry, I comma n. That means for loop that runs from 1 till n. All right. So see here, n is as large as 5 into 10 to the power 5, and then ai can be as large as 10 to the power 7. The other thing is that you have to print d1 and d2, right? For each integer, you are not printing d1 and d2, d1 and d2, d1 and d2 in different line. No, you print all of the d1s in the first line and then all of the d2s in the second line, right? So you are going to print it like that. And now, what I'm doing here, just ignore this. This is fast IO, right? For other languages, ignore it, other than C, C++. So I have defined n and x. I'm reading n and then initializing, calling init function, which does nothing but apply sieve algorithm. So I'm applying sieve algorithm to find out smallest prime factor of each integer in the range 1 till 10 to the power 7. This is 10 to the power 7. Why? because AI can be as large as 10 to the power 7. So I've created an array of size 10 to the power 7. Then for each integer, I'm trying to find out their smallest prime factor. If you don't know how to apply sieve to find SPF, as I said, I'll provide the link of sieve algorithm in the description of this video. Right. So now I'm running sieve algorithm, and for each integer I, I'm saving their smallest prime factor in AR of I. So if I want smallest prime factor of 5, I'll look in AR of 5. Right. So after initializing, I'm going through all the n integers. I'm reading x, right? Basically the AI. So we were talking about AI. So this is AI, right? I'll read x, then I'll try to, I'll basically get out its smallest prime factor. In this case, D. When we were discussing in the in the slides, it was P, right? So just is that the smallest prime factor. So it is the smallest prime factor of x for which we are calculating two divisors. So one of the divisors is d itself, right? And the other divisor is just keep on dividing x as long as you can with d, right? That's exactly what I'm doing here. Once we are done with that, it's time to calculate whether we have the result or not. And it depends on whether x has more than one prime. If it only has one prime, that prime would be this only, right? Because this is smallest prime factor. So if x only has one prime, and that is d, when you keep on dividing it, you will be left with one only, right? So if x is equals to 1, that means it only has one prime. You can print -1 -1, right? So since we are printing d1 first, and d2 will print once we have printed d1 of all numbers together, what I'm doing, I'm printing d1 only, and d2 I'm saving, right? As you can see, I've created an integer array to save all the d2s, and the number of integer can be as large as 5 into 10 to the power 5. So I've created an array of say 5 into 10 to the power 5. So I'm only printing d1, and d2 I'm saving so that I can print in the next line. Right. So basically, if x is equals to 1, that means it only has one prime factor. If it only has one prime number in its divisors, the result is going to be -1 -1, because result doesn't exist. So I'm printing the d1, d2 I'm saving as -1 so that I can print it later. Now, if x is not equals to 1, solution exists, and the solution d1 is d, this one, the smallest prime factor, and d2 is going to be your x. So d1 I'm printing here, d2 I am saving, which is x, right? So after I have gone through all of this, d2s I have already saved, and d1 I have already printed. Finally, after going through all of the integers, I'll print the next line, and after that I can print all of the d2s, right? So yeah, this is the solution. I'll also provide the link to the solution for this, right? So yeah, you have solved a problem which is rated 2000, right? So yeah, this is it for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.